So I always enjoy, hello everyone, by the way. I always enjoy when we get into talking about databases. Um, because for a large part of what we're going through in this class, we try and mimic the real world, quote unquote real world, and try and get you ready for the real world. But unless you're using and storing data in databases, you're missing a big portion of what quote unquote real world programming is all about. Um, so, this is always an important chapter because every real world application that's in production, that's at any sort of scale, that people are using more than, one or two people, or maybe a small office of 10 people. Any real world application with many users, more than, probably 10, I would say, there's going to be a database behind that application. Okay. Databases are everywhere when it comes to, digital online applications. They're behind every transaction that you swipe your card. They're behind every website with usernames and passwords and e-commerce. They're behind every social media site that you use. They're behind every mobile app. They're behind, databases are everywhere. Data is stored everywhere. Obviously, that's what, maybe not obviously, but that's ultimately what databases do, is they work with the data. And so this is a really important, fundamentals chapter. Here you are, you're in second semester. Some of you are at your first semester. And I would say that these database concepts you're going to have in every semester after this. Well, I would say in your second year. So your third semester, you will cover database concepts again. In your fourth semester, you will cover database concepts again. So the idea is by the time you graduate, you'll have these concepts really honed in and fine tuned. So databases are extremely important. They're everywhere. They're behind every application that you use, whether it's a game or an e-commerce site or a social media site or a search engine, whatever it may be. Databases are everywhere. They're extremely important. Looking through these objectives, kind of get down to the third one. For 1 and 2 talks about multi-user system, multi-user database. I mean, that's any application that's been built, in the last 20 years, or multi-user, multi-database, multi-user system, multi-user database. The third bullet there is a key word that I want to highlight. Is a relational database. Okay, so a database is a storage unit. Essentially a database is a file. Like an Excel file has an XLS file extension. And so when you really get into, what is a database is a file, and this file obviously grows. It could be huge. It could be many files, not just a single file. And for example, the database could have a file extension of MDF. MDF is a file extension, and we'll work with MDF files. So a database is a file that holds data. And a relational databases came out a long time ago. And maybe I need to hit up Wikipedia and find out exactly when relational databases were conceived and the concept was implemented. The way that you could think of a relational database is if you think of an Excel spreadsheet. and you have tabs at the bottom. And on each tab, you have another workbook. Okay, so you have your first tab, and you've got information on that tab. You've got a second tab, a third tab. Okay, now in Excel, those tabs, you could link them together, but you don't have to. That's what a relational database is the same concept. A relational database, an individual tab is a table in a relational database. And so relational databases have tables. And the main difference is that when those tabs are linked together, they relate to one another. And we'll get into how that relationship is essentially linked together. You think of an HTML document links to a CSS document. You essentially tie them together. Okay, so in relational databases, you have tables, many tables oftentimes, maybe 10 tables, maybe 15 tables, maybe 100 tables, okay? And many of those tables are linked together somehow. In other words, they relate to one another. And there's a lot of benefits to storing information in different tables. Now, when I was new to this, some of the first questions I had is, okay, well, already I'm talking about Excel and kind of the similarities between an Excel and a relational database. So what are the differences between Excel and a relational database? And the best answer that I found to that, and there's a lot of differences between Excel and a relational database. But the best answer, because a lot of people are familiar with Excel, so I like to relate it to something that you're familiar with. The best answer is that behind a real world application in 2020, you don't find Excel. Behind an application, in that, we talked about the different tiers, front end, middle, and back end. In the back end of a 2020 application, you're not going to find Excel. In the back end of an application in 2020, you find a database. And so databases are meant to tie into applications that are front end applications, whether they're Windows applications that like we've been creating all semester. We've been creating these Windows applications that run on a desktop. A better word would be a desktop application, right? Whether it's a web application that runs like Instagram and Facebook, those are all web applications, and Amazon, those are web applications, or whether it's a mobile application that runs on your mobile device. Behind all of those is a relational database most of the time. Now, again, modern databases, relational databases, probably since the 50s or the 60s, have been relational databases. Relational databases have been around forever. Okay, now they do have another database type that's not a relational database, and we'll kind of get into that a little bit later. I don't need to. For now, we're going to focus on relational databases. But suffice to say, it's not the only database type that's out there. Okay, so again, bullet 3, we're talking about tables. We're talking about relational databases. Bullet 4, really talks about how do you link tables together. Okay, tables have rows and columns, much like an Excel spreadsheet. And ultimately, again, when I was new to this, I would imagine if I'm building an application, I'm just imagining one giant spreadsheet. One giant spreadsheet where you just essentially throw all your information into it. And, sorry, I got something in my eye here. That's not the way a relational database works. A relational database, instead of having one giant spreadsheet with all the information in it, there's a lot of disadvantages to that. So relational databases take all that information and they break it up into much smaller tables. and then you just link those tables together. So instead of having one giant spreadsheet, one giant table with all your information in it, the information is broken down into smaller tables, and then those tables link together. And there's a lot of benefits to doing that. And so, we gotta learn how they link together. Now, to work with databases, okay, there's a standard language called structured query language. So bullet 5, SQL. Structured query language is the standard, the ANSI standard, right? So it's the recommended way for working with databases, right? It's a different language, right? So we've been learning C# all semester, right? We're going to learn structured query language, and some of our labs that we're going to do here in the next week or so are going to be labs not focused on C#, they're going to be labs focused on SQL, okay? And then once we learn some SQL, next week, the following week, we're going to learn something called link. Okay, so we're going to learn really two different ways of interacting with these databases. So what do you use SQL for? You can use SQL to create a database. You can use SQL to create a table. You can use SQL to link tables together. You could use SQL to delete tables. You could use SQL to insert data into tables. And you can kind of see on bullet 5, insert, update, delete, and select. Sounds a lot like those CRUD operations that we're talking about that are going to be part of your final project, right? So you can use SQL to say, okay, well, I want a list. I want to select all of the students that are in the second section, the afternoon section of the C# class. And so in the database, you might have a ton of information, but you're going to select, you're going to read, you're going to select a subset of the information and put that subset of information in a result table. Okay, so when I'm looking at bullet 5, you see select, insert, update, and delete. Those are 4 SQL commands, but there are many more. It's a language, right? So there's many commands, including loops and including if statements, etc. The most common command in SQL, the most common by far, is select. So when we're learning SQL, I'm going to make up a statistic here. I don't know how common it is, but I'd say 90% of the time, totally made up, 90% of the time you're going to be running a select command. And so we're going to focus our learning around select. We're going to do the other commands. We're going to practice them, but focus on select. All right, bullets 6 and 7. For the purpose of this class, we're not going to stress those, what I would call data access techniques. And so 6 and 7 are how you, in the .NET framework, there's a lot of ways to work with data. And one approach is ADO.NET. I'm going to focus you guys, instead of using ADO.NET, we're going to use something called link. Because link is language independent. It's not just in C#. And so we're going to learn a data access technique, a way of working with data that's a little bit more universal than ADO.NET. And really bullets 8 and 9 go into that. So looking at slide 4, this is just such a common slide. It doesn't matter, if we're in the HTML class or if we're in the C# class, it doesn't matter. It's just common slide. The idea here is that across the network, which is related by the cloud, typically across the internet, you access data in a database server. Ultimately, a database server is a computer. Obviously, I always say obviously like it's always going to be obvious, but it's not always going to be obvious. A database server is a computer. Now, a high-end server is a really expensive server. It's a really expensive computer. Whereas your laptop has one processor, a really expensive database might have, 8 processors. Your laptop might have, several gigs of RAM. A database might have, again, many times more than that, maybe terabytes of RAM. I don't know. Might have, an incredible amount of storage. Terabytes, exabytes, petabytes, just ginormous amounts of storage. Obviously, data access and working with the hard drive is where the data is stored. Data is stored on the hard drive. So if you're talking about Facebook, right? You're not just even talking about one server. I don't know how many database servers Facebook has, but to suffice to say, millions and millions, hundreds of millions of users, you're looking at thousands, tens of thousands, hundreds of thousands of database servers for many reasons. For redundancy, so that if one server goes down, you don't lose the data, right? So you have redundancy. For network loading, what I mean by network loading is if one server is overloaded, maybe the processors are 99% utilization, you could share that work with another server. So this is a simple client server. The idea is multiple users can access the data on a single server, but it gets much more complex, obviously, multi-client, multi-server. So the clients are the users, the server. Client-server is a relationship. And so whoever hosts the thing that you want access to, that's the server. In this case, the data that you want access to is the database server. The client might be the user who's trying to log into the website. Hey, here's my username and password. They send it to the server to see if it's a valid username and password, and then the server responds with with the welcome page or with the home page of the website. Obviously the networking is just the routers, the wireless routers, the wired routers, the cables, the Ethernet, the maybe coax cables, the fiber cables, and so on. Right, so they go through and they talk about, again, different types of client servers. Just typically, clients are typically desktops or laptops or cell phones. Servers are just computers, but many times servers have a different form. And what I mean by a different form is they're not in your typical desktop form. There's blade servers. They're in a different case, is what I mean by that. And then the LAN, the big difference for the network, you've heard of local area network. That's like at your home. All the devices that are connected into your router at your home is considered your LAN. But then if you start expanding that, maybe all of the homes in your neighborhood would be considered a wide area network. And so a wide area network is typically defined by a geographic area. And so you could say, well, all the all the devices in the St. Louis metropolitan area could be a WAN. So you got St. Louis WAN, and then you got, Detroit WAN. So it's typically geographically defined versus something that's smaller, which would be a LAN. And so the client says, hey, I'm trying to log into Facebook. You see there's something called a SQL query. Again, SQL is the language, structured query language. And it sends a query, and a query is a request to the database server. And the request might be, hey, I'm talking. Can you guys, is everything going good? Can you hear me okay?
Yep.
Yeah.
Good, great.
Yep.
Okay, just wanted a little feedback from you. A query, again, is a request. It says, hey, I think this is a good username and password. Give me the results of that. In other words, here's my username and password. The results could be good. The results could be bad. Good username and password or bad username and password. But essentially, a query is a request. And you see on the client side, it says it runs the application software. And so the application software might be the software that you're writing. You're building the application software with C#. And the data access API, again, an API, if you've heard of that before, an API is just a library of code. Okay? And so ADO.NET is one data access API, right? But we're going to use LINQ. And so it's just what library of code do you use to access the database, right? So in addition to your application software, you need a data access library, and we're going to use LINQ.
Is Mr. G, is ADO, is that obsolete going out?
Yeah, ADO is getting a bit dated. Yeah. I would say, if you're building something new today, you might use, it's definitely dated. So are you going to find applications out there that utilize it? Maybe. It was a prominent thing for a long time, but more modern applications probably use, if you're wanting to stay only in the .NET framework. So we're learning C#.NET. If you're wanting to stay only in the .NET framework and not, LINQ is independent of the .NET framework. If you wanted to do that, you would use something that's newer than ADO, something called Entity Framework. And so there is something newer in the .NET framework for that purpose. But yeah, I would say ADO is obsolete. Okay. On the server side, okay, you have the key thing on slide 7 is a database management system. It's called a DB, database MS, DBMS, database management system. And there are many database management systems. Let me just do a Google search, DBMS wiki. Database management system. So the database management system is the software to run the database. If you want to run an Excel spreadsheet, you run Excel. If you want to run a PowerPoint, you run Microsoft PowerPoint, right? So the database itself is the file. To work with the database, you run a database management system. Right, and you see these go back to the 60s. So databases have been around for a long time. Relational. The common database management systems. There's a lot of them. There are a lot of them. The most popular, the number one database management system, DBMS, is Oracle. Oracle database management systems, the last numbers I saw were about 60% of the total. So Oracle is the leader. Okay. Oracle databases historically worked a lot with Java applications. Okay. Now, the second most popular, actually, I don't see it in the list, is the Microsoft product, Microsoft SQL Server. So we're going to be working with the second most popular because the database, we're working in the stack, the Microsoft stack, right? And so you get what are called stacks of technology. And so oftentimes, because you're working with C#, you're going to stick with the Microsoft stack, right? But if you're working with a different stack, maybe PHP works with MySQL databases. Okay? So SQL Server is the second most popular database management system. It typically runs with Microsoft products. MySQL is for your PHP. IBM has a database management system called DB2. That was the former king. The former king before Oracle was an IBM database. They used to have the largest market share. And so, again, we're working with Microsoft SQL Server. What's confusing about, I don't know, SQL is the language. The software to run a database is called Microsoft SQL Server. And so it takes the language and puts it as part of the title of the management software. So now, when we're working in Visual Studio, I just made this empty solution. You have to have Microsoft SQL Server installed on your laptop. So part of the confusion when you look at what we're doing here is we see different computers. We see a client computer and we see a database computer. Separate computers. But in development, your laptop is going to act as both. Your laptop is going to be both the client and the server, which is kind of weird, right? It's like, well, you're showing me that they're two different things, but then in practice, they're going to be one thing, right? But in the real world, when you go to use this application, in reality, they should be different things. They will be different things. Okay, so the database server will likely be a server that holds the Microsoft SQL Server. Microsoft SQL Server is running. By the way, the database server always powered on, right? Because if you power the database off, you can't get access to the data. So it's always powered on, and it's always running the database management system, the Microsoft SQL Server. So that software is always running. If you close it, like even if I close Discord here, right? It's still running. Discord's still running. I could see Discord running right here, right? So Discord is still running on my computer. The database, Microsoft SQL Server, when you put it on a database server, it's always running. So the point that I'm getting to is, hey, when you're in development, like we're in development here, your laptop is going to be both the client and the server. Now, depending on the options that you chose, when you installed Visual Studio, you might have downloaded SQL Server Lite, the Lite version, the free version, the version that's not meant for huge enterprise applications. You might have, you might not have. In fact, if I go to my toolbox, you're very familiar with the toolbox, but there's also a tool called Server Explorer. Now, if you don't see that tab of Server Explorer, you might have to reset your window layout. If you accidentally close that somewhere along the line, you might need to do that. Reset your window layout. And if I go to create a SQL Server database, I right-click the connections. By the way, there's always 100 ways of doing this, in Visual Studio. This is just the easiest way that I want to show you. Create a new SQL Server database. It's going to say, hey, you need the package for SQL Server. Do you want to install the packages? Okay, go ahead and do that. So I wanted to put that in this video, and you'll notice it takes you back to the Visual Studio installer, and we need to run that install. Not sure if you can see that going. So you guys can go ahead and get that installer going, because we will need to do that. And again, that was just an option for you to click when you were installing Visual Studio.
What did you click on again? The prompt to download? Because I got that tab open there, the Server Explorer.
I right-clicked the data sources and I said add new SQL Server. Or no, I said add new database. Excuse me. I said add new database. Obviously, my Visual Studio is closed right now, so I can't show you. But I right-clicked the data connections and I said add new database.
Add connection or create new SQL Server database. That's what I see.
Yep, add new database. Once this installs, I should be able to get back into it. I'll come right back to this. So you now know what a database management system is in here. Now the other term on the first bullet is just a network operating system. Typically your servers at home, you might run Windows 7 or you run hopefully Windows 10, right? On a server, you just got a different operating system. It's probably still Windows. Again, we're in the Microsoft stack. So if we're in the Microsoft stack, we're still running Windows. And Windows has Windows Server, and then they just have a year. It goes back to Server 2000, which is kind of funny because that's the first server product I learned. I actually got certified in Windows Server 2000. If you guys ever want a certified technician to work on Microsoft Windows Server 2000, you're looking at your guy. But since then, they've had 2003, then they had 2008, now they have 2012 and 2016. After 2016, I don't even know the version, but it's just like Windows, right? You get Windows. Oh boy, see if I can do this. Windows NT. Then you had Windows 3.1 that was popular. Then you had Windows XP, which was awesome. Then you had Windows Vista. Then you had Windows 7. Then you had Windows 8. Then you had Windows 10. They forgot how to count. And you get the idea. So anyways, the network operating system is installation has completed. Paul, did you click that? Did you have the option on data connection?
Yeah, it's done. Thanks.
Okay. So now we're looking at something different. And that's probably that might time out on me here. Hopefully that doesn't lag out for you guys. I'm going to show you how to work with that here in a minute. Again, your client software is the front end that we've been building all semester. And the way that the client and the server interact are through queries, SQL queries. In the SQL query, again, there's the four common ones. I said the most common is select. So select is going to say, give me all the students in this particular class. And so they go through and they say, hey, you know, most modern applications kind of split the workload between the client and the server versus what they call a file handling system where they put all the work on the client. And so this is what, this is what a single table could look like in a database management system like Microsoft SQL Server. Okay, so you get this create new SQL Server. So it doesn't show me the options there. I might need to save this for another time. Typically for the server, you just put your computer name, and that might be all that you need. So if I look at my computer name, okay, great. I've got this laptop NJ. I'm kind of doing two things at once here. Let me drag this over here. And I might need to install more software. Just doing that one little install might not be enough. See if that works. It might time out because we might not actually have that DBMS, that database management system. We might not actually have everything we needed to install. Sometimes in here you get, that's why I was going to look at this processes and see what's running here. Yeah, I don't see Microsoft SQL Server running here. So let me go down to my, I'm pretty sure I'm going to need to install SQL Server. Yeah, what this is saying is it can't find the connection to SQL Server. And so sometimes, let's look at servers. Yeah, I don't have SQL Server running, so I need to go back to the installer. This is actually not a bad thing to put in the video, because I'm assuming a lot of people are going to need to do this. So I might have the installer in my downloads already. Yeah, I already have it in there. So instead of re-downloading it, I'll just go to my downloads and search for Visual Studio, Community, run it. I'm going to need to close Visual Studio to do this. So essentially what I'm going to look for is a server software, Microsoft SQL Server. Of course, it wants me to update this first. Okay, so this is going to take a little bit of time, so I can come back to the lecture. What I'm looking for is Microsoft SQL Server, but they have different versions of it, just like there's a community edition of Visual Studio, which is the free edition. I have to find the free edition of Microsoft SQL Server. Getting back to slide 12. When we're looking at a single table, again, okay, what's the difference between Excel and Microsoft SQL Server table? Well, one thing I will tell you that is a big difference, okay? In Excel, when you have a column, you don't have to have a data type on Excel. You could put someone's name in one row of a column, and then you could put a number, and then you could put, a date in the next row. So columns in Excel don't have data types, but columns in a database management system do have data types. And so just as we've been learning data types all semester long, in C#, there's another list of data types in SQL Server, and they don't match 100%. It would be nice if everything was like a perfect match. They don't match. And so the data types in SQL Server are similar but different. For example, a string. A string in SQL Server is called nvarchar. And typically you put max in parentheses. So a string in SQL Server is called an nvarchar. Now what that stands for, the N says that this is Unicode, which means that for every character it takes up 2 bytes of storage. Varchar. Varchar is a variable length, that's var, character. So you could have a variable length characters, I should say, plural. So you could have no characters, you could have 1 character, you could have 1,000 characters. And then max says that there's no limit to how many characters there could be. Like if you said 1,000, well then that's 1,000 bytes of storage. And so there's only so many characters. If every byte is 2, then you get like 500 characters, something like that, okay? But typically it's nvarchar max. And so you can see that there's data types in Excel, and the columns have data types, okay? You can also, on the columns, you can also set up rules that are called constraints. And so your columns, not only do they have data types, but your columns can also have constraints. And so, a constraint on this column for unit price might be that unit price cannot be negative. So that's a rule on that column that says you cannot insert a negative number. And if the application tries to insert a negative number, the database throws an error. Okay, so again, you could handle that in your application. We've learned how to handle, that scenario in the application, and we know how to put in error handling to say, okay, if the number is negative, don't allow it. Okay, but you can also have the database protect. So essentially, you're protected at the application for no negative numbers, and you're protected at the database for no negative numbers, right? So data validation. Now maybe you start to see you can do data validation on the front end and the back end. The back end being the database, the front end being the application. And so that's really the best practice, to do your data validation in both places. And they break this down into, okay, every table has rows. They also call them records. Okay, and when you intersect a column and a row, they call that a field. So it's just terminology. That's called a field when you intersect. Now here's a really important term on the 4th bullet down. All right, this is a really important term that maybe you've heard of this before, maybe not. I would guess that you haven't. Most tables contain a primary key that uniquely identifies each row in the table. And so remember earlier I was talking about these tables are all related, and somehow they're related. Well, they're related through what are called the keys. And there's more than one kind of key. We just learned about a primary key and its function in an individual table. The purpose of a primary key is to say, okay, every row is unique. You're not going to have two rows that are the same. Somehow these rows are going to be different. If Billy, makes a purchase and you're going to store that information in the row, and then a day later Billy makes the same purchase, so the same person buys the same thing, somehow those two purchases have to be different. You can't have the same rows, two of the same rows in a table. And so you label a column as a primary key column. And then what happens is if you get two rows that are the same, potentially the same, the database throws an error and it says, no, you can't do that. It doesn't allow it. Just like it wouldn't allow a negative price, it would throw an error and not put the insert in, not put the data in. A primary key is looking out for that purpose. Every row is unique. So that's a really important bullet. Very important bullet. Okay, the next bullet talks about constraints. We've already talked about that. And the last bullet talks about what's called an index on a database. And an index on a database is just like an index in your book. Like if you want to look up something quickly in a book, in a physical book, you go to the index and you look it up. Say, oh, this is on page 500. So you flip to page 500 and you're able to look things up faster. Databases have what are called indexes, and it helps the database retrieve information faster. Let's look at this. Okay. So I've got an old Visual Studio 2017 that I'm not working with. Let me modify my 2019. Here's my SQL Server, and I don't even know what I checked that wasn't checked before. But see here, it does say SQL Server 2016. That's exactly what I need. Express is the free. Local DB. So it does look like local DB is installed. And so I was assuming that I needed to install something else. But I think by checking this option, which I had everyone check at the beginning, that it does look like local DB is installed. So based on this, I should not need local DB is installed. That's exactly what I need. So it doesn't look like I need to install anything else. So let me bring this back up. And I might just need to type in local DB into that box. I think that might be the solution. Okay, so I'm kind of doing two things at once, which is good. Okay, this is a good point for a break because we're going to talk about how tables can be related. And I need you guys to kind of be fresh. So why don't you guys take 15 minutes. I'm going to pause the recording. And it's a really important topic when we come back. So I'm going to pause. Okay, we are back. And took a second while I was on break to figure out what needed to be done at this step. When you click on Server Explorer, and you go to add a database, the trick is always what goes in this box. And I knew it was something with local DB, but it's always a little tricky to figure out exactly what goes in there. You got to find the server. And so the solution, as you hover over this SQL Server Object Explorer, I click on that button, and it opens up this tab. This tab was not open before. And there's the answer. Local DB / that name right there, \. And so that's what you need. That's what I needed to populate the box with. What this is the version of SQL Server, which is called local DB. That's the free version. Then after the / is what's referred to as the instance name. And so you can have many instances of SQL Server installed on your machine. We just have one. We have one instance, and that instance is called MS Microsoft SQL Local DB. And so if you copy this whole line right here, copy that out, we go back to our Server Explorer, add a database, paste that in, and I'm going to call this database ranking. It spins up our new database. Now, ultimately, what's behind this database is a file. So a file has just been created on our laptop, probably called rankin.mdf, and I could find that file. You can go to the file properties and find it on your computer somewhere. It might require a little digging, but it's on there nonetheless. And I can see that there are no tables currently in this Rankin database, but I could create a table using SQL. There's a create table command that we'll come across, and I'll do that in just a little bit. Okay, but those were the steps that were needed to create our database. So we now have our database created, and from there, we can create tables. Right-click, add new table, and you can write the code. This is SQL, or you can use a GUI to create the table, and the GUI is going to be right here. And so again, you can write SQL or use a nice little pretty interface. And so we will do that. I did not create a table at this point. I just closed that tab. Back to this slide 14. Okay. Let me look at slide 14. Let me piece this together. So we have invoice ID and invoice line items. Okay. This is not a good slide to demonstrate exactly. Oh, yeah, it is. Yeah, it is. Okay. Looking at the top table, and I struggle to even tell if that's the invoice table or the invoice line items table. It looks like the invoice table. Yeah, the top table is going to be your invoice table. That makes sense. If you look at the leftmost column is called invoice ID. Very commonly, your primary key, remember the primary key has a job of uniquely identifying each row. So very commonly, your primary key is an auto incrementing counter. I guess it just starts at 1, the next row is 2, the next row is 3, the next row is 4, and it just automatically increases for every new row. It just creates a new number. And so that's what we have going on here. On that top table, you have invoice ID. Invoice ID is the primary key for the invoice table. And it's just an auto increment. It's kind of grayed out there. The next table is invoice line items. Do you see invoice ID on the second table? And if you take a look at the second table, it goes 41, 42, 43, 44, 45. So it almost looks like an auto-incrementing counter, and this is what tricked me up. I didn't see, it looked like an auto-incrementing, but when you look down, you see 46, 46, 46, 46. So that's not a primary key. It is a primary key on the top one because there's no duplicates on the top table. And so the assumption that you come to there is that that's a primary key. The invoice ID is not a primary key on the second table. So the way that these two tables would be linked together would be through that column. You could see they have the same column name. So we would have to write some code to link those two columns together. What that column is called on this bottom table, it's called a foreign key. So tables are linked together through their keys. A primary key has the job of uniquely identifying each row, and a foreign key simply relates back to a primary key in another table. And so you would say that that foreign key column links that table to the top table through that column, through the key values. Again, it's a primary key in the top table. It's a foreign key in the bottom table. Now again, foreign keys do not enforce uniqueness. You'll see that invoice ID, it looks like there's multiple items on that invoice, like 46. 46 has 1, 2, 3, 4 different products. It's one invoice, but it has 4 items on that invoice. And so invoice number 46 has 4 items. And so now what does a foreign key, what rules does it enforce? A primary key enforces uniqueness. A foreign key says, you know what? In order to have a line item, an invoice line item, you have to have a valid invoice ID. So the rules on that bottom table, the constraints, if you will, on that invoice ID is that it has to be a current and valid invoice ID from the invoice table. In other words, if there is no invoice ID of 100 in the top table, you cannot insert an invoice ID 100 in the bottom table. So again, the foreign key enforces a rule that says in order to insert a foreign key value, that value must first exist as a primary key value in the table that you're linked to. That concept right there is very important. Okay, understanding that what is a primary key, what is a foreign key, and their relationship between one another. Now, to code that, I think this slide just expands on what I just finished saying. Foreign keys, foreign keys, foreign key table versus primary key table. You wind up having, just like we had in our UML diagrams, we had one-to-ones, one-to-manys, and many-to-many relationships. you have those between your tables. And I need to expand on those types of relationships here in a little bit. Any questions on primary key versus foreign key? Is that making sense, or are you feeling lost?
I'm good.
Anyone else care to chime in? Is anyone? I mean, any part of this? It's an important topic. Now, your final projects, I am not requiring multiple tables. So in the final project, we're going to stick to one table for the requirements. Now, in a real world application, you're going to have more than one table, but being that this is your first exposure to databases, we're not going to make it overly complex for your final project. We are going to do one table, and in reality, for everything that you have on your UML, for every item on your UML, it could relate to a table. So for every student in your UML, and you look at all of the fields, all of your instance fields, all of your instance fields become columns. And so the student becomes a student table, and then the instance fields become your columns. And then you have to match up the data types as best as possible. And so if you've got 2 items on your UML, in theory, you would have 2 tables in your database. In the real world, a very clean database would have all of these tables would be linked. That's called, it's part of a process when you're designing your databases. There's a process called normalization. And I think of it as just getting your database into a normal format. And a normal format is when you have a bunch of tables that are all linked together through their keys. In short, there's a little bit more to it, but in short, that's a big part. Okay? So normalization is a process of getting your database into a normal format that's accepted, as normal, as good. Okay? But it doesn't mean that all your tables have to be related. A database that is not normalized might have a bunch of tables that are not related to one another. Okay, and that's more common than it should be, right? A good clean database is where all the tables are linked together. But it doesn't have to be that way. And so for your final projects, I'm not requiring that if you do have multiple tables that they be linked. Okay, again, this is your first exposure to this, so I'm trying to make it a little bit, I'm trying to reduce the complications. One table is required, and if you do have multiple tables, they don't even have to be linked, although very traditionally they are. Now, this slide 16 looks a lot like that screen that I was showing you when I went to create a table, and you could use a GUI to create a table. This is what that GUI looked like if you were just looking at the table design. This is what this would look like. You could see a column called Invoice ID, and you see the little key there. That means it's a primary key. And then you see the data type on that column is an integer. Now, I realize the column is Invoice ID, but it looks like a row right now. Don't let that confuse you. Each one of those rows is going to be a column in your table. So Invoice ID is a column, Customer ID is a column, Invoice Date's a column. And then you'll again remember each column has a data type, and then whether it's nullable is a checkbox. You could say yes, sales tax can be left null or not. Okay, and you can see that on this invoice table there is another foreign key column. Customer ID is actually coming from a customer's table, and you can see that on the right. There's a foreign key called invoices to customers. So the link is between the invoices table and the customers table, and the column ID is customer ID. So this invoice table, even though we didn't talk about it in the previous slide, it has a foreign key of its own. And that foreign key is the customer ID column, which relates back to a customers table. And in that customers table, there's a customer ID that's a primary key in that table. So these are your data types in SQL Server. Again, they don't relate perfectly into C# data types. And the reason being is that SQL Server is kind of programming language independent. It doesn't really care. Like, you could be writing PHP with a SQL Server backend. Probably not going to happen. It's not realistic. You typically stick to your stack, and PHP would not use SQL Server, but it could. Okay, and so it doesn't really care what programming language you're in. These are the SQL Server data types that you can put. And so it makes real sense, hey, you got floats, and so floats could be converted from SQL Server data into a float in C#, right? We got decimals in SQL Server, we got decimals in C#, we got date and time in SQL Server, we got date and time in C#. So a lot of them do convert pretty well. But sometimes you have to find out, okay, it's coming out of the database as a money data type. So what data type do I need to convert that into in C#? And it just depends, right? If the money data type can hold the $, well, then you might have to figure that out. You might have to parse that dollar. You might have to substring that out. You might have to remove the $. If you want to store it in a decimal, for example, you're going to have to substring off the $. So converting between data types, when you read data out of a SQL Server and you store it in a C# variable, might require you to cast or convert. Oftentimes, if you don't know what the data type is on the SQL Server side, in C#, you could just store it in a var. Remember VAR. We've used vars, I think, at this point, which is just a generic data type, so I don't really know what it is. This is a diagram, a database diagram, that shows you that all the tables are linked, except for we got this kind of orphaned table called order options, and obviously that one's not linked to any other table. Again, in a perfectly normalized database, you would want all of them linked together. So those are the big concepts, okay, in databases. Creating a database, creating a table, giving the columns a data type. Maybe I'll take a minute here and just show you how we can do this. So again, I kind of left off here with our Rankin database. And I can right-click on.
Mr. Junior, I got a quick question. Back on that diagram there was the double circle thing right there. Is that indicating that that's the primary key right there?
The primary key is indicated by the yellow key on each table. So customer ID is a primary key, state code is a primary key, invoice ID is a primary key.
It's just that category, but isn't there like a primary key of all the primary keys? That's the invoice ID, right?
No. The invoice ID is only a primary key in the invoices table. It's a foreign key in the invoice line items. Now, you might say, wait a minute, I thought that yellow key, invoice ID, meant it's a primary key for that table. You notice on invoice line items that invoice ID and product code have a key next to it. That's called I think it's called a compounded primary key, where two columns together make up a primary key. So invoice line items, okay.
Well, I think I get what you're saying there. It's kind of like a first name could be a primary key together with a last name. Two people can have the same first name and two people can have the same last name, but it's very unlikely it's both.
Yeah, exactly. So, I want you guys to look at this. Here's another thing that is part of the normalization process. Okay, so if we just think about it, an invoice has a bunch of products. Invoices have a bunch of products, and a product can belong in multiple invoices. Okay, so if we're thinking about that scenario, a single invoice could have many products. That's a one-to-many relationship, and a product can have could be on multiple invoices. So what's created there is called a many-to-many relationship. An invoice can have many products, and a product could have many invoices. Okay? Many-to-many relationships, and they talk about this up here on the fourth bullet with the common types of relationships: one-to-many, one-to-one, and many-to-many. Okay? Many-to-many relationships, and for a lack of better understanding myself, many-to-many relationships are just considered bad. And I don't exactly know what problems they cause. When it comes to database normalization, part of the process in normalizing a database is removing all many-to-many relationships. So you get rid of them. And the way that you do that is you insert a new table, and in this case, that table is invoice line items. So what you create is a one product to many invoice line items, and then one invoice to many invoice line items. So you can see the symbols. The key means one. The infinity, I think that's the infinity symbol. That means many. So you have a one to many from products to invoice line items, and you have a one to many from invoices to invoice line items. And so what essentially was done is that relationship was normalized. You removed the many-to-many relationship, which was one invoice could have many products, and one product could be on many invoices. You remove that by inserting this new table, and that table's given a name. I can't think of the name off the top of my head. They give a special name to this table. It's called I can't even think of. Gosh, I'll remember. It's escaping me right now. But they give that table a certain name, just call it the unique table, whatever it is. I forget. And you have a one-to-many and another one-to-many that are created. And typically what you do is you have those compound keys that act as together as the primary key. Was that I think, Paul, I don't know if I answered. Did I answer your question?
Yeah, it wasn't two dots, it was an infinity symbol, and I get it now, one to many.
Got it. I think I gave an over explanation, but it was you drew my attention to that, which I'm glad you did. The select command is the most common command in SQL, in the structured query language. This is a syntax of the select command. You're going to be doing labs with the select command. And next week, as early as next week, you're going to be very familiar with the select command because I'm going to give you a whole bunch of practice with it. But again, select is your read statement. You say, okay, select these columns from a table where these conditions exist, and you can sort it and you can order it and all that kind of fun stuff. And so you see we're selecting two columns from the customers table where the state is Washington and you're ordering it by the name column. So the sort is alphabetical on the name column. And so what you're looking at is called a result set, right? That's not a table itself. It's just the result of a query. It looks like a table, but that table is not stored in the database anywhere. It's just the data that's in a table format. That's called a result set. There is a query at the bottom of slide 21 that's kind of a, hey, just give me all the data, is select star. Select star from customer says give me every column from the customer's table. When you're doing a select and you're like, hey, I want data from more than one table, you have to do what's called a join. You have to join tables together. Again, we're going to get lots of practice doing joins. And so you'll notice here on this select, we're selecting from 3 different tables. We're selecting from the invoice line item, we're selecting from the products table, and actually just 2. We're selecting columns from 2 different tables. And then you see the keyword join there. We're going to join tables together by basically saying, hey, these 2 tables are joined together by their keys. So a join lets you select data from 2 different tables to put it in a single result set. Right? Most of the time we're just going to be doing inner joins, which returns data when the related columns match. So we'll be doing some inner joins next week. Okay, there's an insert command. Now the insert is to add a new row. So you add a new row of data. So it's like, hey, we have a new customer, we have a new product. We're inserting a new row into our table. Update is maybe, hey, we want to update the price of one of our products. So you want to update data that's stored in your database with the update. Again, select is the most common, but we'll practice. And then delete. Obviously, delete's the most dangerous. If you want to go ahead and get fired at your job, go ahead and delete some data that you're not supposed to, and you'll be collecting unemployment a lot faster than you would have liked. Right? So be careful with delete. Delete is dangerous. Don't delete your customers. Don't delete your invoices. That will get you fired. Okay. Now, these last handful of slides are dealing with the ADO.NET concepts that we are going to not use these. So these last handful of slides, this is some C# code that would be using that ADO.NET. Again, not necessary. So that's the end of the PowerPoint, of the relevant parts of the PowerPoint. Let me finish up with a little demo here. And then I'll get you going on some labs after the video. So we've connected, we've made a database table, add a new table. And you can type in here. I've created tables using SQL, and you can kind of see what it's doing. The name of the table goes right here, and so I'll just call this student. DBO is what's called a schema, and it basically says who can access who can work with this table. And DBO stands for database owner, is essentially the administrator. And so, that's kind of a common schema to work with. You can, for the most part, leave DBO unchanged. You can see by default, it wants you to have a primary key. And so student ID is by default a primary key. And if I go to properties of my student ID, there's a properties window over here. It's very common for your primary key to be an auto-incrementing counter. And so what I'll do is I'll set is identity to false. We're going to change it to true. And when I change that, the identity specification to be identity, it sets the seed, basically the first student will be student 1, and the increment will increment by 1 at a time. And so I changed that property. Now you'll notice it changed my create table. Student ID is an integer data type. Here's our data types. Obviously more than what we saw in that chart. But it is an int. We do not want it to be empty, so it's not nullable. It is our primary key, and it is our identity. Identity is really what enforces the uniqueness. It could be a primary key without identity, but identity enforces the uniqueness. First name column, nvar char, and again, this is the number of bytes that it could take. I'm just going to say max.
So generally, we're going to have something like line 3 there, where it's going to be a primary key and a unique identity.
I think you might have been getting some feedback, but yeah, generally you're going to have a primary key. Generally, it's going to have identity. So I'm going to keep my student table pretty simple. And then to run this and actually create the table, you have to click Update Database. As of right now, if you save this, you're not actually, like if I just click Save, what it wants to save is the SQL script, the actual code that we wrote. It wants to save this, but it hasn't run this code yet. To run the code, we're going to click Update, and that actually lets you can either generate the script to run later. I'm just going to click Update Database. And you get our little output here that said update completed successfully. Now by default, you're not going to see the table there. You need to refresh. And so you can kind of collapse this, click on the refresh button, and now I've got a student table. So I can close the SQL. We don't need that anymore. We already created our student table. And if I open the table definition, that's how I get back to this screen, by looking at the definition. Again, right click, open table definition. If I want to show table data, this is kind of a cheating way to insert new data, right? You could use SQL to insert data, but if you just wanted to, who am I going to... You can see the auto-incrementing counters working. And so that actually did insert the data, and I can right-click, show table data again. You can see the tables there. Now, in order to just write whatever SQL you want, you generate a new query. So I will select the first name column from student. You can see we got some IntelliSense there trying to help us out. And then we get those 3 rows. So let's select last name, comma, first name from student. So you can see, even though our result table, we could put it in any order that we want. You know, we could select the last name, then the first name, then the student ID. We could change it all around. You know, and you get the general idea here that this result table.
Mr. G, what are those tabs down there? TSQL results message.
I don't see what you're looking at.
It's in blue. It's TSQL. Does that just mean table?
Oh, good question. So it's in blue. The whole screen's blue. I don't know, but it's really royal blue. Okay. Good question. Good question. SQL is a standard. Oh, clearly that's not a SQL comment. What is this? Yeah. So SQL is the standard. There are, depending on your database, there are different versions of SQL. Transact SQL is the Microsoft version of SQL. So Transact SQL, they took the standard, Microsoft took the standard and implemented it into a language called Transact SQL. And so Transact SQL is a version of SQL. Procedural SQL, Transact SQL is also, that's the T-SQL that you're looking at, right? So it's Transact SQL, T-SQL is the Microsoft version of SQL. Procedural SQL, also called PL SQL, is the Oracle version of SQL. And Transact SQL actually does not enforce semicolons. You notice I did not write a semicolon here. One of the big differences, procedural SQL enforces semicolons. So you know how in C# everything is terminated with a semicolon? In Visual Basic, that's not the case. In Visual Basic, you don't have to write semicolons. It's kind of like there are a lot of similarities, but there's some small differences between T-SQL and PL SQL. So in blue, that's what we're looking at. This is Microsoft Transact SQL that we're writing. If we want to sort it by last name, click Start. Notice now we're sorting our students by last name. Student ID.
I see it's not case sensitive.
Not case sensitive. Yep. So those are some basics. Creating tables, querying tables, inserting data into tables. Of course, if you wanted to delete, you could delete, let's see. So then you can just highlight that. Let's see if my syntax was good enough. One row affected. You can execute one at a time just by highlighting. And so if you highlight it and you click the execute, it's only going to run the highlighted code. So now when I select star from student, you'll notice I remove Jennifer. Right? So we can read, we can insert, we can delete, we can do all of our CRUD operations with our SQL. Okay, so I think that's a good stopping point for this lecture today. Let me go ahead and stop recording.